So let us discuss the next experiment. So that is the implementation of multiplexer and demultiplexer. So how the multiplexer and demultiplexer are implemented. So to do any project, so you need to create a folder. In the folder, you need to create the project. So let us know once again how to create a project, right? So we are creating a folder. While creating a folder, we need to select the device and other specification. Since this is starting labs, let's go once again. We have created a folder, the project name. So HDL lab, same file we are creating. So then RTL project. So then select next. So then add source. So here you need to add source, right? So whatever the constraints are there, so you need to select the product category, family, subfamily, package, speed grade, and temp grade. So all these selection will be same for all the experiment, right? So since it is a beginning, so we are doing once again how you are going to select the categories and all, then give finish. Then in the project summary, so whatever we have selected, so that will be displayed here. So then I need to add source. I need to go for add source. Which experiment we are doing? We are doing multiplexer and demultiplexer. So we call it as mux and demux. Here the mux and demux outputs are decided by the select lines. So select lines will be there depending upon the select lines. So whatever the input will be there, that appears in the outputs. So mux 4:1. So 4 inputs are there, 1 output will be there. We have decided. So let us select the select line, right? Select line will be of 2 select lines are there, since I have 4 combination, right? So if it is 2:1, 1 select line was sufficient. So then 4 inputs are there, right? I0, I1, I2, I3, right? Then I will have 1 output. Generally I will represent by y. So y of since it is 1, I can declare as outputs. So without initializing LSB MSB, no, don't select the bus. Now the skeleton for multiplexer is ready, right? Just we need to write the program. So depending upon the select lines, so whatever the input will be there, that appears in the output, right? So here we have y. So that y appears depending upon the select line. If select line 0, 0, I of 0 appears. If the select lines is 0, 1, I of 1, 1, 0, I of 2, 1, 1, I of 3 appears. So then let's go for test bench. So let us go for providing a test bench. Test bench basically to feed the inputs, right? Input signals are there, right? So let us give the input signals. All the input signals I can give it in test bench and I can see them, right? So let us use the same variables so that there won't be any confusion, right? So then I can able to see so inside that mux 4:1, so I need to have the test bench, right? So what are the combination of the test bench, right? I need to have the 4 combination select lines, right? Select line I can have 0, 0, 0, 1, 1, 0, 1, 1, right? So then I will get a result. Right now input patterns is ready and the program is ready. So then we need to run the simulation. After that all program is over, then go for run simulation. If there are errors, so it's providing an error, so you need to rectify that error. So it's not mux 2:1 since it is 4:1. So then the variable declared was wrong. Save and run the simulation, right? Since you have done 2:1, so you are using the same, so all these errors will come into the picture. So we are introduced to have the debugging. So we call it as debugging whatever the errors are corrected. So let's maximize them and see. Whenever the inputs are, the select lines are 0 0, right? So whatever the signal, right, is available, so that appears in the outputs, right? So 0 1, right, 1 0, right, whatever the data is available, so that appears in the outputs, right? So if 0 0, y of 0, if I2 is active, so then I will have 1 0. If I3 is active, I will have 1 1, right? So whenever you are changing, so here also the signals are changing, you can verify that. So this is implementation of marks 4:1. You can implement 2:1. So one select line is sufficient. You can implement 8:1. For 8:1, you require 3 select lines. You can write the truth table and you can verify the design, right? So once these okay, so then your intention, your objective has been achieved, right? You can cross verify that for all the combination, right? Whatever the test bench combination we have given, so you can verify that. So similarly, you can implement demultiplexer, right? So here in 4 outputs and 1 inputs in case of multiplier, whereas demultiplexer 1 input 2 outputs, or 1 input 4 outputs, or 1 inputs 8 outputs. So you can implement any of that. So let's go for implementing of demultiplexer. So now we have completed multiplexer. So then let's go for implementing of demultiplexer. We need to give demux. So how many inputs? 1 inputs and 4 outputs, since it is 1:4. If it is 1:2, 1 input, 2 outputs. Then declare the variables. So that is inputs and outputs. Select line is required here also, right? And inputs is required and output is also required, right? So how many select lines? 2 select lines, 1 inputs, 4 outputs, y0, y1, y2 and y3. So there are 4 outputs are there, right? So check once properly, so then you give okay. You need to verify properly, so then you need to give the okay. So that is, you have decided the ports. So the ports are inputs, output pins, which are inputs, which are outputs. It need not be I as an input or Y. You can interchange that. So you should know what is input, what is output. So they are variable names. Yeah. So now the skeleton is ready. So then we need to write an equation. So 4 outputs should come. So for all 4 outputs, I have written the equation y0, y1, y2, y3. Depending upon the select lines, the input appears at the outputs. Then go for providing a test bench. Add create simulation source. So wherein which you can provide the test bench. So demultiplexer 1:4, 1:4 underscore TB. Test bench should be saved underscore TB. Right? Use the same variable declaration as we have decided. Right? So then let us see. So these variables are provided and signals are initiated properly, right? I have the combinations, right? 0 0 0 0, right? So whatever the I is there, so you can see I of I equals to 1, I equals to 0 for both the select lines are 0 0. Whatever the signal is there, that appears in the output, right? So we have run the simulation and we can able to see the results. Maximize, right? So depending upon the select lines, depending upon the select lines, if it is 0 0, so whatever the signal I0 is available, that appears at the Y0, right? Here it is 0 0 and select line is 0 0 and input is 1, hence it appears at the output. So we are keeping the select lines same and we are changing the input 0 1 0 1 0 1 0 1. So whatever the select lines, so the status of the input that appears correspondingly with respect to the outputs. Here it is 1 0, but input is 0, so hence 0 is appears. Here it is 1 0, since I is 1, so that I of 1 is appears at Y of 1. So then input is 0, right? So hence your I, Y0, Y1, Y2 all are 0. Since it is I, so then I will have 0 0 1, right? So whatever the test bench, whatever the truth table you have decided, so need not to provide the I values, right? You can keep the I values constant and you can cross verify that, since we have kept all tables, so to verify all the combination, so it need not be. So whatever the values you have taken, so that appears at the outputs. So this is with respect to the implementation of demugs. Thank you.